If you put your company's database directly on the public internet, you are going to get hacked. Not maybe, not someday. Constant automated scanners will find it. To survive in the cloud, you need to build an invisible fortress around your resources. Today, we're breaking down the AWS Virtual Private Cloud, or VPC. By default, the AWS cloud is a massive, shared public space. Millions of customers all run their stuff in the same cloud. A VPC is how you rope off a private, isolated section of that space just for your company. It's your network boundary. Think of a VPC like a corporate office building. First, you put a fence around the entire property so not just anyone can wander in. That fence is your VPC. Inside the building, you divide the space into rooms. In AWS, those rooms are called subnets. There are two rooms you need to understand right away. The first is the public subnet. Think of this like the front lobby. The doors face the street. Anyone from the outside world can walk in and knock. This is where you put things that must talk to the internet, like web servers. The second is the private subnet. This is the vault in the basement. There are no doors that open directly to the street. You don't put anything here that strangers should touch. This is where your sensitive systems live, especially databases. Now, let's talk about why this split matters. It gives you total control over traffic flow. When a user visits your website, their request comes from the internet and passes through something called an Internet Gateway. That gateway is attached to your VPC and acts like the front door in the fence. From there, traffic is allowed into the public subnet. Your web server receives the request, does its job, and if it needs data, it talks to the database sitting safely in the private subnet. The database sends the data back to the web server, and the web server sends the response to the user. At no point does the outside world touch the database directly. That separation is the entire security model. Even if someone attacks your website, they still can't just reach into the vault. Here's an exam tip you need to remember. Private subnets are private by design. They do not have a route to the internet. But sometimes a database or back-end server needs to download updates or patches. It still can't use the normal front door. Instead, it uses a NAT gateway. A NAT gateway is a one-way mirror. It lets servers in a private subnet reach out to the internet, but it blocks any inbound connections from the outside. On AWS exams, if a private resource needs outbound internet access, the answer is almost always a NAT gateway. So, how does this look in real life? This is the first architecture you build in AWS. Traffic starts on the internet. It flows through the internet gateway attached to your VPC. From there, it reaches EC2 web servers running in a public subnet. Those servers then communicate internally with an RDS database running in a private subnet. Each step adds another layer of protection. Your data stays isolated, your attack surface stays small, and your design scales cleanly. Once you understand this pattern, you can recognize it everywhere. It's the foundation of secure cloud architecture. Now that you've built a secure network, there's one more problem. What happens when a million users all try to walk into your front lobby at the same time? You need a traffic cop. Click the next video to see how elastic load balancing keeps your application from falling over, and I'll see you there.